We are now going to look at the law of cosines. The law of cosines relates the lengths of the sides of a triangle to the cosine of one of its angles. And it states that given a triangle labeled with angles A, B, C, and side lengths lowercase a, b, c, we see that c squared is equal to a squared plus b squared minus 2 times a times b multiplied by cos of c. The law of cosines works for oblique triangles as well as right-angled triangles. Note that if c is the hypotenuse in a right-angled triangle with a 90-degree angle at capital C, the cosine law reduces to the Pythagorean theorem. This is because cos of 90 degrees is equal to 0. Okay, let's look at how to use the law of cosines and when it's appropriate to use it. We can use it if we're given two side lengths and an interior angle and we want to find the third side. The law of cosines can also be used to find a missing angle if we know all the side lengths. Notice in this diagram, which our cosine law is built with, we have angle A that faces side length A, angle B which faces side length B, and angle C which faces side length C. Notice that within the formula, our angle C is contained between side lengths A and B. Notice we can also write the cosine law for side length B squared and A squared, such that we have angles B and C that are the contained angles with the respective sides. Let's do some examples. In this first example, we are given two side lengths, an angle, and we want to find the third side K. The law of cosines relates the three side lengths to the cos of an angle, therefore we will use the law of cosines to solve for K. First, we identify the contained angle and the two sides that contain the angle. Now we write an equation for the side length that is across from the contained angle. Therefore, k squared is equal to 8 squared plus 11 squared minus 2 times 8 times 11 times the cosine of 37 degrees. Now evaluating this all in one step on your calculator, you get 44.44015023. A few things to note here. We need to make sure that your calculator is in degree mode since our angle is expressed in degrees. And also perform this all in one step on your calculator and leave that answer in your calculator to reuse it again. All we've done so far is solve for k squared. K squared is equal to 44.44015023 and so on. Therefore, to solve for k, we must take the square root of that value. For k is equal to the square root of 44.44, so on. And evaluating it, you find that k is equal to 6.67 feet. Before I plugged any values into my calculator, I should have checked that the units of all the side lengths are equal, and see they're all currently expressed in feet. And then when we plug them into our formula and evaluate it, the units of the missing side will be the same as the original units of the other sides. Now we have another example where we're going to calculate angle D in the triangle below using the law of cosines. We're given three side lengths and have a missing angle. First thing we do is figure out which two sides the angle is contained between. We have angle D, and it is contained between the side length with side length 5 and the second one with side length 9. The left-hand side of our cosine law will be written for 8 squared. So recall our cosine law. The 8-meter side length is the side on the left-hand side of the cosine law, and that's the side opposite your contained angle. So that is opposite, and you would relate that side to C from our original formula. Recall our original law of cosines that c squared is equal to a squared plus b squared minus 2ab times cos of c. When we are solving for the missing angle, we must first get cosine of c by itself. Using some algebra, we can rearrange this equation. Therefore, we get the cosine of c is equal to a squared plus b squared minus c squared divided by 2ab. Make sure you use brackets in the numerator of your fraction to ensure that you divide all of the top of the fraction by 2ab. Now we can plug in the values. We know that we get 9 squared plus 5 squared minus the side opposite our missing angle divided by 2 times 5 times 9. That is equal to the cos of c. And when we evaluate this, we find that it is equal to 0.4666. Now to solve for c, we need to take cos inverse of that ratio. So leave the value in your calculator to reuse it, and we find that it is equal to 62.2 degrees when we round to 1 decimal place. And although I've solved for c in the formula for the cosine law, in the diagram that angle was labeled as angle D. Therefore, we say that D is equal to 62.2 degrees. We've now looked at using the law of cosines to find a missing angle as well as a missing side length. Given the appropriate information, we can now solve oblique triangles using the law of sines or cosines as appropriate. In the next video, there will be lots of practice questions to apply both formulas.